So we're going to look at example 5 now, and example 5 is a little bit more complicated than the previous examples. So in this question we're told that we have a hollow propeller shaft of diameter ratio 3:5. In other words, this internal diameter is 3/5 of the outside diameter. We're required to transmit 600 kilowatts at 110 RPM, the maximum torque being 12% greater than the mean. The shearing stress is not to exceed 60 meganewtons per meter squared, and the twist in a length of 3 meters is not to exceed 1 degree. Calculate the minimum external diameter to satisfy these conditions. And we're told that the modulus of rigidity is 80 giganewtons per meter squared. Okay, so these are the formulae that we've used for all our torsion examples, and I've highlighted here the information that the question has provided. So the first thing anyway is we're at 110 RPM, so that equates to 11.52 radians per second. Tau is 60 by 10 to the power 6. G is 80 by 10 to the power 9. So we have G and we have tau. I don't know the diameter, so I'm just saying, or sorry, I don't know the radius, so I'm just saying it's the diameter over 2, outside diameter over 2. It's a hollow shaft, so the second polar moment is pi times d to the 4 minus small d. Well, small d in this case is 3/5. So small d is 3/5 of the large d. And 3 divided by 5 is 0.6. Power is torque times omega, so we were told that power was 600 kilowatts. And we have omega as 11.52 radians per second. So I can rearrange that and get a value for the torque. So the torque is 52,083 Newton meters. So that would be the mean torque. And we are told that the maximum torque is 12% higher than that. So I'm going to multiply this value by 1.12 to get 12% higher value than what this is. So 1.12 is times 52083 works out to be 58,333 Newton meters. Okay, so I'm going to use that torque value then and substitute it back in here. Right, the second polar moment, J is pi d to the power 4, and the ratio is 3:5, so 3/5 is 0.6, so it's 0.6 d to the power 4. I'm going to get 0.6 to the power 4, and that's 0.1296. So this expression becomes 0.1296 d to the power 4. I can now take d outside the brackets, and I get d into d to the power 4 into here goes once, and d to the power 4 into this goes 0.1296. So 1 minus 0.1296 is 0.8704. So pi times 0.8704 divided by 32 is 0.08545. So J is equal to 0.08545 d to the power 4. Right, so we're going to keep that value there. Now we're going to take this equation down. The torque, we calculated that previously as 58,333. The J is 0.08545 d to the power 4. this is 60 by 10 to the power 6, and this is d over 2, and everything else is just the same. Okay. So the value theta here, we were told is not to exceed 1 degree, but theta is measured in radians, so we have to convert this 1 degree to radians. So 360 degrees is equal to 2 pi radians. So 1 degree is 2 pi divided by 360 radians. So 1 degree is, so when I divide 2 pi by 360, I get 0.0175. So the value of theta here now becomes 0.0175 radians. Okay, so that's my equation. I'm going to take this part of it first. And first thing I'm going to do is get rid of the d over 2. Nope, I'm not going to do that. First thing I'm going to do is cross multiply. So this value here is going to go up to this position, and this 60.6 is going to go down here. So what I've done now is I've multiplied 0.085445 by 2. I get 0.1709, and d divides into the d to the 4 by d to the 3 times. So I just rearrange that then to get an expression for d cubed. And when I put that into my calculator, I get d to be 0.178 meters. Okay, so that's the minimum diameter that it needs to be to satisfy the shear stress spec. All right, we now have to look at the angle of twist specification. And to do that, I'm going to use these two parts of the equation. And what I'm going to do is cross multiply again, so the 3 times the torque value, and d4 comes up to here, and I bring the 80 by 10 to the 9 and 0.0175 down here. Okay, so we're really just cross multiplying. So that gives us a d to the 4, so I get the 4th root of all of this. So it is the 4th root of 3 times 58333 all over 80 power 9 multiplied by 0.0175 multiplied by 0.08545, and that gives me 196 millimeters probably. But seeing as the answer was 195, I'm going to keep it at 195. So we get 195 millimeters. Right, so we had two solutions. We had 195 and we had 178. As this is greater than the 178 value, then this is our solution, and that matches the master answer.